Okay, so in this problem, we're going to figure out the maximum height reached by a ball. Okay, so we're going to toss something with the speed of 30 meters per second. We're going to figure out what is the maximum height it reaches. All right, so once again, we start with our chart. So let's put everything in: delta x, vi, vf, a, and delta t. Now, what are the things that we need? Okay, what are the things that are given? We know that the speed with which it starts is 30 meters per second. Okay, because it says that, hey, the ball has to go up. Now again, a common mistake people make is that they assume that Vi is 0. Now remember, if you just let go of the ball, it's not going to go up. Okay, so don't worry about the fact that it was at rest in the hand at some point. We don't care about that. The hand has already tossed it up, so that's what we're interested in, and that's when gravity takes over. So remember, in this case, Vi is 30 meters per second. Okay, we also know that A is negative 9.8 meters per second square. And we're looking for maximum height. But we all understand that we need at least 3 things in these problems. Okay, so you have to ask, hey, what else is going on? And this is where we rely once again on the physics of the situation. So what's happening as we toss something up? Okay, or what happens at the highest point? Okay, what we know, our experience tells us that if I throw something up, it's going to come back down. Now if it's going up and then coming back down, then clearly at the highest point the object must stop. Okay, and that is our condition. So at the highest point it must be at instantaneous rest, okay, or rest for that instant, and we have Vf is equal to 0. Now we have 3 things. We do not care about time. We're going to use equation Vf square equals Vi square plus 2a delta x, and this will give us 0 square is equal to 30 square plus 2 times negative 9.8 times delta x. And so this will end up giving us 0 equals 900 minus 19.6 delta x, and this implies delta x is equal to 900 divided by 19.6 meters. And you guys can figure out the values, and all that could be done. Okay, so understand the problem. Here we had to use the condition. Okay, you have to come up with the condition that the final velocity would be 0. Now be very careful about assuming Vf is equal to 0. There is only certain conditions when you can do it. So if you're told maximum height, you can assume it for one-dimensional motion. If you're told that an object comes to rest, okay, eventually, then you can use Vf is equal to 0. But you cannot just make Vf 0 without having good physical reasoning behind it. Alright, that's the end of that problem.